So for inferential statistics, we basically are just trying to consider, is our data reliable or not? Because if my data is not reliable, then I can't make some broad statement about humans or about the population as a whole. So how do we know if our statistics can be inferred like that? There's 3 keys that we look for, and you should know these. One is that representative samples are going to be better than biased samples. If you remember, we talked last week, and if we have a population, to make sure that that population is representative, we have to pull randomly from the population. So I can't do, let's use this example. I have an example listed of comparing intelligence scores of breastfed to bottle-fed babies. If I'm trying to make a generalization about breastfed versus bottle-fed babies in the United States, I can't go into one hospital in Madison, Wisconsin, and find out who's breastfeeding and who's bottle feeding and then compare that data. That does not give me any sort of an accurate representation. It might not be representative. Madison, Wisconsin is maybe not as diverse of a city as Chicago. The income level is probably quite different. So that sample that I'm taking, if it's just from one city, isn't going to be representative of the country as a whole. So that would be a biased sample. So we always want to make sure our population is representative of the entire population we're studying. Less variability in our observations mean that it's more reliable. So if my data points are everywhere and my bottle-fed scores are all over the place and my breastfed scores are all over the place, then I'm probably going to look at my data and say, oh, I cannot rely on this. It's not reliable. It's too variable, so I can't make these generalizations about it. And then the third thing is that more cases are better than fewer. So again, I can't study 10 women who breastfeed and 10 women who bottle feed babies and say, oh, yep, this is true to the whole population, because those numbers are just too small. There's too much room for error there because there's so many differences in humans already that those 10 aren't going to give me a good picture. So to use inferential statistics, we need more data points really to help us out and to help us make those decisions. So if we've determined that we think our data is good and we want to use it, the next step is to kind of think about if it's statistically significant. And this is another kind of big term that they throw at you a lot on the AP test. But basically in psychology, because like I mentioned, humans are so different and we have so many different ranges of emotions and intelligence and just genetics that it's really hard to have ever 100% of something in psychology, because there's just always someone who's a little bit different, but we can speak in general terms. And so instead of having 100%, we try to go by 95%. So basically in psychology, 95% is our proof that something is true. And so that's what we would call statistical significance. It's represented by a lowercase p. So if you ever see that like p equals something, you know that it's referencing statistical significance. And then P stands for how likely the results were due to chance. So if P equals 8, that means there was an 85% chance my data was just random, basically, and so it's not good data. We want a lower number there. P has to equal less than or equal to 5% for us to feel confident in stating that our results are significant. So that's the cutoff. It's just a number you have to know. It's P equals less than, P is less than or equal to 5%. If that is true, then we can say that our results have significance and that our data has some sort of meaning. If that number is bigger than 5, then we're starting to think, oh gosh, there could be some other factors here that are messing with our data. We maybe can't really rely on that data. The biggest thing that you have to take away from this slide, if you're copying it down, is really that the P equals the less than, P is less than or equal to 5%. And then understanding that P references this idea of things being statistically significant. Do our results matter? Can we trust them? Can we continue with that research? So if you remember, we talked about this a little bit, and I'm going to reinforce it every time because I think just being able to write the FRQ isn't enough. I think following this criteria is really important, and so I really reinforce this with you guys. So remember to be concise in your FRQ. You should not be writing like pages for each term. You should be writing a paragraph for each individual term that's listed. Make sure you're checking your handwriting. I know that like when you're feeling cramped for time that's hard, but if I can't read your FRQ, then you're not going to score points for it on the AP test. So make sure you practice that now. Underline, you should always underline the term just because it draws attention to it. You know, these people are sitting in a room grading papers for like 10 hours a day, and so they can make mistakes. They're human. So the more things that we can do to help them not make mistakes, the better off we're helping ourselves. And then you're getting rid of extra stuff, meaning we don't write a conclusion or an intro. We just get right into the meat of the response. Make sure we space out our writing, so we leave a space between paragraphs. You should respond to the prompt in the order it was given. You should define every term and apply every term and use synonyms when appropriate. So my prompt that I came up with, and this is actually a pretty common prompt in research methods, because usually what they'll have you do is either design an experiment or critique some sort of experiment. And so this time I went with the design and experiment route. So this is pretty common. You might see something like this if you haven't taken your research methods test yet. And it also often pops up something similar on the AP test. It says to design an experiment that tests the hypothesis cooperative learning is more effective in raising test scores than direct teacher instruction. Use the following terms in your response. So then it lists independent and dependent variables, random sampling and assignment, ethical guidelines, and an interpretation of statistically significant. So this one is a little bit different because you have to first set up some background. So typically you would just start with independent and dependent variables, but it's asking you to do something else. You have to set up the experiment because the rest of your responses depend on what you write in that experiment. So if you don't write about the experiment, you're not going to score any points because there's nothing to reference what you're talking about. So you just have to give, it can be really basic. So what I wrote is, to test this hypothesis, we could design an experiment where one group of Ms. Ravello's students are given instruction directly via the teacher and the other use cooperative learning. After 2 weeks, we could measure their test scores and see how they vary based on instruction. So I have to now use my experiment that I came up with in all of the rest of my responses. So you're going to be using that as we go. An independent variable, then, you start with the definition, is the factor that is manipulated or changed in an experiment. The dependent variable is what is being measured. Those are just straightforward definitions. You don't have to get fancy there. You just show me that you know what the term means. Now, how do I apply that to the experiment? That's the key here. And so in the above experiment, the independent variable is the type of instruction, because that's what some get and some don't. And then the dependent variable is the subsequent test scores. And that's really all you have to write there to get that point. You've identified, you know what the terms mean, and then you've identified in the example what those terms are. So it's pretty straightforward for that one. The second term could be a little bit trickier. And so it's asking us to define random sample and random assignment. Again, we're just basic definition. We would have left a space here between our paragraphs and then just start with, a random sample occurs when each member of the population has a chance at being selected. So if the population is Miss Ravello's psychology class, you need to now tell me how you're going to take a random sample from that class, because that's applying it to the scenario. So the easiest thing to do is put everyone's name in a hat and draw 20 names, because everyone's name has a chance of being put into the sample. Random assignment refers to the fact that members of the sample all have an equal chance of being in either group A or group B. And so you could literally just say, again, for this experiment, we're going to put those 20 names back in the hat and draw 10 for group A and 10 for group B. And that's how we'll do it. So again, you need to stick with whatever you wrote in the original experiment, because that's what they're going to look at for comparing whether or not you're talking about the term correctly. Ethical guidelines we haven't talked a lot about, but it is in the research methods unit, so hopefully your teacher went over them. But defining ethical guidelines, you would just list that there are rules in psychology that should be followed during an experiment. And then specifically, you'd probably want to list what they are. And so the big ones that you need to know for AP Psych is that we should do no harm. We need to debrief or talk about the experiment when it's over. People have to give informed consent, meaning I can't force you to participate in an experiment. And then lastly, it needs to be confidential. I shouldn't be like sharing your test score saying, oh, look at Susie. She did so much worse on this test than Jimmy did. And then that is not nice and you shouldn't do that. That's a breaking of confidentiality. So I've defined ethical guidelines. And then in this experiment, I would talk about maybe one guideline that isn't being followed. So one concern of this experiment might be informed consent. If Ms. Ravello forces her students to participate, then she would be breaking an ethical guideline. To avoid this, she should have all students sign participation agreements beforehand. Rosemary is asking if we wouldn't have to define each ethical guideline. No. Unless it lists a specific one, like debriefing or confidentiality, you could probably just pick one that you feel the most comfortable or the most confident talking about and apply it in that scenario. They're not going to make you write about 4 different ethical guidelines in that one little FRQ spot. So typically you can just pick the one that maybe seems the most obvious. Sometimes there'll be one that's really obvious. Otherwise, just pick whatever you feel best with. That would be the way to go. And then the last one, sometimes kids struggle with this because it says an interpretation of what statistically significant results would mean. And so they're like, oh, that's not a vocab word. But you can still pick out the vocab word here and define it. So clearly it's referencing statistical significance. And so that's how I would start by defining statistical significance. Statistical significance refers to whether or not a result would have occurred due to chance. Sometimes, too, if you're uncertain and you're just going to try and define a term, you're also not going to get docked for writing more information. They might not grade it and they might not score it, but if you're uncertain and you want to try and approach it 2 different ways, you could write, as long as you're not contradicting yourself, you can write more information. So it doesn't hurt to do it. You just might run low on time. But it doesn't hurt to try. It's not going to cost you any points in the long run. So we've talked about what statistical significance is. And then basically I have to make up some statistical significance in my experiment because that result wasn't given. So in this particular experiment, let's pretend that statistical significance is 3.1%. Now you need to talk about what that means. You have to show you understand what statistical significance is. That means to us as experimenters that we can determine that our results are not due to chance, and therefore the teaching style of cooperative learning versus direct instruction has an impact on student scores. For us to feel confident in our data, it would be wise for us to do this experiment many times over with a larger sample size. So that last sentence was probably a little bit of an add-on. It wouldn't maybe be necessary, but it kind of rounds out and shows your understanding of what we want to do with data and how it helps us determine whether it's significant and whether we can infer based on that to the rest of the population. So that's just a broad overview of the FRQ. If you guys have more FRQ related questions or want to see more examples like this, I can post some in the Facebook group. Otherwise, like I said, we will be doing these every other week. So next week, we're going to focus again on multiple choice questions, and then we'll go back to FRQ and we'll kind of alternate back and forth because those are the 2 big skills you really need to develop for the AP test.